So in this video we will be seeing how to add the section to the PE file. So you can add another section and you need to modify some of the fields, and those fields are the number of sections count in the file header. You need to increment this one, and the size of image. So the image size increases, and how to calculate this is the last section's virtual address plus virtual size. This gives the image size. And the size of headers. So we have the header size. You need to increase by one image section header. I think these three, and finally we gonna paste that section header after this this last section. So let's get started. I have already written these add section 6432 and they are working fine. So let's do this again. So I have calculated the file alignment. So the file alignment tells us at which multiple of this one the section should start. So here we have file alignment 200. So if there is a section at the starting of 400 and the section only occupies 100 hexadecimal bytes, then the next section should not start at 500. It should start at 600, because this should be the section starting should be multiple of this one file alignment. So that's why I had fetched the file alignment. So the function takes two parameters. One is the PE file and the second one is the shellcode. So if you look at the PE file in the hex editor, you can see the last one is section is obviously nulled out. So you can open calculator. 1A00 divided by 200 gives you this calculator does not use shows the remainder. So this one is the best. 1A00 divided by 200. So if you calculate this one, you get remainder 0. So that means we are good to go. Sometimes you will have some extra bytes here. In that case, what you need to do is you need to first let's calculate the PE file dot length. So this gives me the whole size of the raw PE file. So it should be divided with the file alignment. So 1A00 is divided by 200, which gives me the quotient. So the quotient is in this case it's D, and the remainder is 0. So what we're going to do is, if suppose assume that there are extra some 10 bytes, then what you need to do is you need to skip this from 1A00 to plus 200, which gives you 1C00. So you need to start the section at that offset, because there are 10 bytes and you cannot continue at 1A something. So you need to add 200 for this. So what we can do is let's just assume for now 1A00 there are already null bytes has been added to the section, so that we can directly add these bytes. So at the end of this video we are will be fixing this one. So let's say PE file dot length by file align. and we need to add +1 to this one. And we need to multiply with this file align. So the quotient will be d 200 into d +1, that is e. You will get this 1c00. So let's say 200 into e, so which gives us 1c00. So perfect. So this gonna gives us the total size after the section was added. So let's call this as new section size. New section size is this one, and let's calculate total size is equals to total size PE length, and we need to add that new section size. So let's run this. So I think at the new section size we will have the 1600. So let's okay. So we have added 1A00 and 1C00. So that's, we can remove this one, new section size. So we can see the total size is 1C00. And sorry for this, we need to add the shellcode.length. Yes, shellcode.length by file align. So both will be, I think, similar. So the new section size is 200, and we can add this PE file.length. So in the previous case, what we have done is we have calculated the new total section from this one, but here we are taking the shellcode length which is some say 100 bytes, and we are dividing with this file align. So you will get some quotient, and you will add +1 to this and multiply with file align. So you will get the new section size. So we got the total size 1C00, how much we want to allocate. So we can say virtual alloc total size and the protection type should be page read write. So we have allocated the size, and at last we need to free this one, virtual free. So we can specify 0 for the size, and we can say mem release. Let's also print the base address. So now at this point we can copy the first. Let's copy the PE file, PE file dot length. So this should copy the PE file, and then we need to copy the uh, shellcode 0 and base address plus PE file dot length, and the length is shellcode dot length. So let's put a breakpoint at here and let's run this. And if I go and step this one, I should see the PE file here, and we can see the PE file has been copied. So if I go and next step into this, I should see the shellcode. Okay, there is my shellcode. So here this is my shellcode, sorry, calc.exe. You can see 1800. You can see at the one ending of 1800 we have the shellcode. So I think we are good to go now. So we have successfully copied the PE file and the section of shellcode into that. So what you need to do is we need to modify this one, these members. So let's go ahead and parse these headers. Image DOS header, you can say DOS header, marshal dot pointer to structure, base address, type of DOS header. So we'll be getting the DOS header, that ELFA new, so we can get the PE offset. And the next one is, let's create a new NT header 64 and NT header dot signature. So the first 4 bytes of PE header is the signature. So marshal dot pointer to structure, and the pointer is base address plus DOS header dot ELFA new, and the type of so it's not a actual structure, it's just 4 bytes. So we can say marshal dot read int 32 base address plus DOS header dot ELFA new. So this should do fine. Now we are good to go. We have the signature, and then we can say NT header dot file header is equals to marshal dot pointer to structure base address plus DOS plus DOS header dot ELFA new plus 4, because the signature is 4 bytes, and the type of NT header 64. So we are good to go now. NT header 64. So Oh, sorry, it's file header. So forgot this file header. So now we need to parse this optional header. Marshal dot pointer to structure. So this is going to be somewhat big because we need to calculate starting from base address, press DOS header dot elfnu, press 4, press. So the size of file header is 20 bytes. I can just say 20 bytes, or you can say marshal dot size of this nt header dot file header. So I think everything is parsed now. Let's just go and print this one, nt header dot file header dot number of sections. We should see the output as 3. So here we can see the number of sections are 3. So let's also parse these sections. Image section header old sections is equals to new sections of how many sections are there? Nt header dot optional file header dot number of sections. So let's go and loop over this. I less than so we can say base address plus DOS header. So this gives me the PE offset. So now what I can say is marshal dot size of nt header. So this gives me directly the offset to the nt header, and after nt header we will have the sections. Okay, at this point we can say old sections of I is equals to image section header. So we have parsed these section headers. After parsing one section header, you need to skip that length of the first section. So how you going to do is we can say plus I into marshal dot size of type of section header. So what this gives is for every iteration I'm going to for the first iteration I is 0, so I will be getting the exact offset to the first section header. For I is equals to 1, I am getting the offset to the first section header. I am adding again the size of this section header, which gives me the offset to the second section header. So in that way I am going to loop all over this one, all over the sections. Now I can say old sections of I dot name. So we can say new string, and if we go ahead and run this, So let's run this, and here we can see we got all the sections. So we are good to go now. So we have parsed everything, the sections, and all we need to do is we going to update these values. So the first one is sections count. Updating sections count. So we need to find the offset of this sections count so that we can update in the byte array. First let's find the marshal dot offset of let's find the offset of this sections count member from the file header. You can see the file header, it's 2 bytes, I guess, this one, and this one is 4th byte. So let's just find out type of file header. So in this structure I want to find the member, that is number of sections. So this string should be unique. I mean this string should be the member of this structure. So you can see the number of sections. Make sure all of these uppercase and lowercase are correct, and we need to say dot 2 into 32. So you will get sections count offset. Now we got the sections count offset. All you need to do is sections count offset is equals to, so from the starting, that is DOS header dot elfnu plus the signature is 4. So you need to add this one. Now you will get the sections count. So the sections count is 16 bits, so 2 bytes. What we can do is, let's just print this PE file of sections count offset plus 1. So we can see we got the 3. So I think we are good to go. Let's go and modify this one. So let's marshal dot write into 16. So we'll be writing to this our memory allocated, and then after that we can finally save all those memory into the file. Base address plus sections count offset. Sections. So we need to update the value. So we can say nt header dot file header dot number of sections plus 1. So we are updating the sections in the memory. So let's put a breakpoint at here and let's run this one. So we have this you can see the PE. So here we can see 0003. So this is in Lithuanian. So 03 is the number of sections. If I go and step into this one, I should see the 4. So let's run this and we can see the 4. So we have successfully updated the sections. In the similar manner, we are going to update all of this one. Size of image. So size of image is, so let's first create a okay, so let's create a new section header. Let's say new section is equals to new section header. So we need to update the values of these new section members like this one. So new section dot name is equals to encoding dot ASCII get bytes of. So here we need to give the name 8 characters, because later we are going to copy into the memory, so it's gonna give some error. So let's just give the dot dummy 69. It takes exactly 8 characters. And new section dot number of line numbers 0, relocations 0, this one is also 0. Now pointer to raw data. So the pointer to raw data is the PE file dot length. So at that the next byte to this one, we have written the our shellcode. New section dot now size of raw data. Size of raw data is this one, new section size. So new section size is the size of raw data. And new section dot virtual size, virtual address. So virtual address is you can see the last sections virtual address is 4000. So let's first define virtual size. So there is some math you should do for virtual address. Virtual size is shellcode dot length. Now there is a problem I have encountered. Whenever this virtual size is greater than section alignment, so that means our section alignment is 1000, and if the virtual size of any of the previous section is 2000, or let's say 1500. Now what we need to do is we need to divide this one virtual size with this section alignment. So 1500 by 1000, so which gives the quotient 1. So quotient 1, we need to add +1 to this one, and we need to multiply with the section alignment. So this gives the the actual virtual size, I mean the next virtual address to this one. So we got the 2000, so this 2000 should be added to this virtual size, so it will be added to 4000. Now the result will be 6000. So you can see 4000 1500 virtual size, and the new section is 6000, so it should be uh, it should be it should not give any error. So first let's go and get the old sections of, so to get the last section member of an array, so we can say old sections dot length -1. So this should give you the last member dot virtual size. Virtual size should be divided by section arrangement. So section arrangement is empty header dot optional header dot section alignment. So this should give me the quotient, and even if the virtual size is 190 here, so you can see virtual size is 190, which is less than the 1000. So we can say 190 divided by 1000, you will get the value of the quotient 0. 0 plus 1 1000, so it gives me the value of 5000. So it should not be a problem of the previous section's virtual size. Okay, so now I'm going to add +1 to this one, +1 to this one, and I'm going to multiply the section alignment. Into this one, so this gives me the perfect value to be added to the old sections of old sections dot length -1 dot virtual size. So that is adding to this the previous virtual address. So this entire thing is new section dot virtual address. Okay, we are good to go. My new section is ready, and one more few more things we need to update are this one, size of image, size of headers. So what we can do is empty headers dot optional empty header dot optional header dot size of image. So size of image is equals to the latest section's virtual address plus virtual size. This gives me the latest size of image. And we need to update this value by finding the offset of this size of image. So I'm just gonna copy this one, so it's similar to this updating values. So let's copy this and paste it in our code. So we are finding the size of image, and then the PE offset plus signature plus the file header plus size of image offset. So we can say this one as updating image size. Okay, in similar way you can update the size of headers as well. So copy this and size of headers. So this is the size of headers offset. Marshal dot base address plus DOS header dot elfnu plus 4 signature plus 20 file header plus size of headers offset. So at this point I want to update with nt headers dot optional optional header dot size of headers plus Marshal dot size of. So we are adding one section, so we can say size of image section header. I think we should be good to go. So let's put a breakpoint at here and let's run this. And at this point the sections number of sections sections count. Oh, it also hit the breakpoint. So 03 should be changed to 04. Yes, we can see. And now the where is this breakpoint? So let's click on continue. At this point image size, so image size is 4190. So the new image size will be this one, the virtual address plus the size, virtual size. So if you click on this one and you should see 5114. So 5000 is the virtual address and 114 is the virtual size. So let's, if you continue this one, we should see size of headers offset. So the size section header is 40 bytes. So 40 in hexadecimal is 28. So if I add 28 the section size to this 248, section header size to this 248, I should get 270. So let's run this one and I should see 0270 270. So we are good to go. One last thing is we need to copy the section header information right after this section. So how do you get the offset is nt header dot option file header dot number of sections. Okay, this gives me the old number of sections, that is 3. What we can do is we can directly write using this one, size of headers. So you can copy this one, this is the correct offset we can write. So Marshal dot so to write this section structure, we need to convert this into byte array. So first let's allocate some memory. So we have allocated some memory and it can be pointed by pointer. And we need to marshal the structure to the pointer. So the structure is new section pointer true. So at this point the section will be copied into this pointer will be pointed to that structure data. So then we can copy this one. We can copy into this new section bytes. Sorry, first one is pointer and the next one is new section bytes start index, and the length is new section bytes dot length. So let's put a breakpoint and let's run this and type pointer. So let's run this one, and here we can see the structure new section structure. You can see the first one is the name dummy69 and the next one are the members of the structure. Those are 40 bytes were written into this one. So we are copying from this one to the new section bytes. So we are good to go now. And final thing is we need to copy this byte array to exactly before this section header. So marshal dot copy new section bytes start index 0, destination is base address plus nt header dot optional header dot size of headers. New section bytes dot length. So let's put a breakpoint at here and run this. And the base address is this one. So hey, here we can see the after this fifth section, after 40 bytes, this is the end of the section. We should see the new section here, the dot dummy69. So let's run this, and here we can see the section information. So we have successfully written this one. So we have successfully added the section. All we need to do is now we need to create an byte array. Let's say new file is equals to new byte of total size. Marshal dot copy source is the base address, new file total size. So we are copying the entire memory bytes into the file. So we can say file dot write all bytes. So we can say D smart teaming tools, and then new file. So let's go and run this, and here we can see the character 3 has been popped up. So let's go and view that character 3 in P bear, and here we can see the number of sections has been increased to 4, and the size of image, size of headers, and if you can see there is a dummy section. So the characters, I forgot about characteristics. So you can copy the characteristics of this one, new section dot. So these characteristics tells the whether section is readable or executable. So there is a enumeration data section flags dot memory execute, and data section flags dot memory read, and data section flags dot I think it's 4. So if you hover onto this, you will see the enum code executable readable content code. So we are good to go now. So let's run this again, and now I read out this one, and we should see the characteristics same as dot text section. We can change these characteristics as well. You can just say readable. So that's all about this video. You can add if you want to add another section, you can randomize this number, and you can do in a loop of adding sections.